bunny.
Yeah, there goes that helicopter again.
Hold it a second, will you, kids? I'd like to throw a little light on what's about to happen here. Would you you lambs, please move out of the way, and could the bunnies come back on?
I know. This is the beginning of an animal story.
No, not at all. This is a mathematics film. It's about addition.
Addition? What's addition?
Addition must be about bunnies.
Not exactly. But I'm going to begin with these bunnies to show you about addition. Could you bunnies manage to line up? I said, could you bunnies please get yourselves together? We want to do some mathematics here. That's better. Now, kids, here we have some furry monsters. Some cuddly bunnies. How many are there all together?
1, 2, 3, 4, 5.
There are 5 altogether.
Right. You counted the bunnies and got 5 all together. Now, as we go on, you'll find that addition is a way to put one group together with another group. Very good, bunnies. You can go now. Okay, little furry friends, don't get carried away. You did a good job. Just move on out now a little more rapidly. Rapidly. I'm beginning to think this is a film about animals myself. Would you lambs please behave? You're as bad as the bunnies. Okay, kids, now we're going to find out how many lamps we have here. Tell me, how many lamps in the first group?
1, 2, 3.
3 lamps.
And how many lamps in the second group?
1, 2.
2 lamps.
Now, if we put both groups together, how many lamps are there altogether?
1, 2,
3, 4, 5. There are 5 lamps altogether.
Right. We say that there are 3 lamps in the first group and 2 lamps in the second group. If we put both groups together, then we get 5 lamps altogether. Okay, lamps, you've shed some light on the subject. You can go now. Bye. Don't forget to turn off the lights.
Wow, what's happening?
Neat, look at that.
Let's get some boats out on this lake and do some more addition. So again, we have 2 groups.
I know, 2 boats in the first group and 3 boats in the second group.
Or 5 boats all together.
Good. You sailed right through that. Sailed right through it. So it's the same as with the lamps. There are 2 boats in the first group and 3 boats in the second group. If we put both groups together, we get 5 boats. Now that's addition. 2 put together with 3 is the same as 5. You boats can ship out now. You too, water. And can we have the roller skates glide in? How many are there? 2 in the first group and 3 in the second group. How many are there altogether?
2 skates put together with 3 skates.
Make 5 skates.
Right.
Hey, what's going on?
We're just rolling along. Rolling along. Don't worry, none of them are leaving. Now, how many in the first group?
3.
How many in the second group?
2.
And how many all together?
5.
There's still 5.
Right again. One group of 3 skates put together with a group of 2 skates make one large group of 5 skates all together. They both equal 5. So you see, it doesn't matter in what order you add the number of objects in the groups. 2 put together with 3, or 3 put together with 2. They still equal 5. Okay, you guys can roll out now. Let's try it with another group.
Wow, look at them all.
And here comes more.
What's happening here?
The same thing as before. We're going to do some more addition. Okay, pilots, cut your engines. See, the helicopters are in 2 groups. How many in the first group?
1, 2, 3.
How many in the second group?
1, 2, 3, 4.
How many all together?
1, 2, 3, 4,
5, 6, 7. 7 helicopters altogether.
Okay, now we have 3 in the first group and 4 in the second group. This makes 7 altogether.
One of the choppers is moving from one group to another.
Well, now the groups have changed a little bit. What do you see now?
I know. 4 helicopters put together with 3 helicopters also make 7 helicopters.
That's right. Now we're buzzing along. Are there other ways to group them? Now remember, the helicopters are just moving around into different groups. Okay, you choppers, cut it. Now, kids, let's do some more addition. Before we put them together, how many in the first group?
1, 2, 3, 4, 5. 5 in the first group.
And 1, 2 in the second group.
And can you add them together?
Sure.
5 put together with 2.
Make 7.
That's terrific. I think you've got it. And of course, if the groups changed places,
Simple. 2 helicopters put together with 5 make 7.
very good. Now that we've been looking at different groups that add up to 7, can you think of another way of grouping the helicopters and still get 7?
I think so. Can there be just one in a group?
Sure.
How about one helicopter by itself on one side and all the rest on the other side?
Okay. Did you get that, pilots?
So we have 1 in the first group and 1, 2, 3, 4, 5, 6. 6 in the second group.
So 1 put together with 6 makes 7.
That's right. And
If they change places, then we have 6 put together with 1 making 7.
let's restate the idea in a mathematical sentence. We can say that 6 plus 1 equals 7. Plus means to add, and we use this sign to represent addition. Equals means the same as. And equals is written like this. So the mathematical sentence looks like this.
Wow, how about that?
Before we finish, I want to show you one last grouping. All 7 helicopters are on one side in one group, and let's say on the other side there are no helicopters. No, really, how would you add that?
7 plus 0 equals 7?
No, don't laugh. That's right. And if we move all 7 helicopters over to the other side,
Don't bother.
We know.
0 plus 7 equals 7.
now let's take one last look at all the groups that add up to 7. You can see that there are lots of ways to group 7 objects, and that's addition. You may want to try grouping the same way. Well, pilots, you can start your engines. Okay, buzz off. Move on out. We're all through now. Hey, you guys, scat. A page of your carrots. This film is over. Would you guys get out of here? Would you please leave? Come on, guys.
What's going on here?
Must be a film about food.
Yeah, health and nutrition.
I know it looks that way, but this is a mathematics film. It's about subtraction.
Subtraction?
Yes, we're going to use all this food to bite into the subject of subtraction. You know, of course, that addition is about putting things together. For instance, 2 put together with 3 makes 5. Now, let's look at how subtraction works. Could the hot dogs come in? Hey, hold it, will you? No, I didn't mean hold the mustard. I meant hold that silly barking. Okay, how many hot dogs do we have?
1, 2, 3, 4, 5.
5 hot dogs.
And let's say that we take away 2. 1, 2. Then how many are left?
1, 2, 3.
There are 3 left.
Right. So we can say that if you start with 5 and take away 2, that leaves 3. There are 3 hot dogs left. 5 take away 2 leaves 3. Anyone want these hot dogs?
No.
Okay. We're through with you, hot dogs. Now, how many eggs do we have here?
1, 2, 3, 4, 5, 6. 6 eggs.
Yeah, 6 eggs.
Okay. Now, let's take away 2 again. 1, 2. And how many are left?
1, 2, 3, 4.
There are 4 left.
So we can say that 6 take away 2 leaves 4. Let's state this as a mathematical sentence. Take away is written with a little line like this. It's called a minus sign. It simply means take away. Now, can you read what it says there?
6 take away 2 equals 4.
Right, or 6 minus 2 equals 4. Okay, we're through with you other 4 eggs. You can slide off now. Could you red apples please get yourselves into a group on one side? Not on your sides, on one side of the screen. Oh, boy. All right, kids, how many apples do we have here?
1, 2, 3, 4, 5, 6, 7.
We have 7 apples.
Okay, take away 1 apple. I just said take it away, not take it away and eat it. Okay, we have 7 apples, and we take away 1. How many apples are left?
1, 2, 3, 4, 5, 6.
6 apples left.
So how would we say that?
7 take away 1 leaves 6.
Or,
I know. 7 minus 1 equals 6.
aptly put. Aptly put. And of course, you know this is how we write it as a mathematical sentence. Okay, since that apple was so good, let's take away another apple. So now we've taken 2 away. That leaves how many?
1, 2, 3, 4, 5.
Then 7 take away 2 is 5.
Or 7 minus 2 equals 5.
That's terrific. You're doing subtraction. Now let's see if you can continue on with the apples.
Well, we could take away another apple.
Okay, you work it out.
Well, we have 7 apples, and we take away 3 apples.
So 7 minus 3 is...
1, 2, 3, 4. 4 apples left.
And how do we write that?
7 minus 3 equals 4.
That's right. And of course you can see that there are other numbers of apples you can take away from 7. Let's go back to where we had 7 apples all together.
Look at that apple.
It's being uneaten.
Okay, we know we have 7 apples here. Let's not take any away. What would you say about that?
Well, nothing would happen.
But how would you write it? 7 take away 0.
Equals 7.
Right. Now let's take away all 7.
Hey, they're all being eaten.
So we started with 7, we took away all 7. We're left with...
None. 0.
And how would you write it?
7 minus 7 equals 0.
Very good.
It sure looks like we're through with those apples.
You can say that again.
It sure looks like...
No, I just meant you're right. You apple cores can go now. Now, let's do some more subtraction. But this time, let's find out how many were taken away instead of how many are left. How many cupcakes do we have?
1, 2, 3, 4, 5.
6, 7, 8, 9.
9 cupcakes altogether.
And let's say that someone comes in and eats some of the cupcakes. How many cupcakes do we have left?
1, 2, 3, 4, 5. We have 5 cupcakes left.
How many were eaten or how many were taken away?
How are we going to find the answer?
I know, just count the empty wrappers. Then we'll know how many were eaten.
1, 2, 3, 4.
There are 4 empty wrappers.
4 cupcakes were eaten.
So, 9 minus 4 equals...
5.
That's right. 9 cupcakes minus the 4 that were eaten means 5 are left. Could you please clean up that mess? Thank you. Again, let's do another problem. Now, how many ice cream bars do we have?
1, 2, 3, 4, 5.
6, 7, 8, 9, 10. Wow, we have 10 ice cream bars.
We better hurry or they'll melt.
No, these can't melt. Okay, just like with the cupcakes, let's say that someone comes in and eats some of the ice cream bars.
Wow, look at that. Boy, they eat fast.
Now, how many ice cream bars do we have left?
1, 2, 3, 4, 5, 6, 7. We still have 7 ice cream bars.
And we want to find out how many were eaten. So, how do we do it?
I know. We'll count the sticks left over. There are 1, 2, 3. 3 sticks left over.
So 10 minus 3 equals 7.
Well, there you have it. That's subtraction. It's about taking things away and finding out how many are left.
What's going on here?
Yeah, what?
Attention, people and things. This is a mathematics film. It's about multiplication.
I don't understand.
What's multiplication?
Yeah,
Multiplication is one way to describe objects you see every day. Want to see how it all works?
sure.
Yeah.
Okay.
Neat.
Okay, cut your engines, please. Quiet. Now look closely at these cars. See how they're arranged? They're arranged in order. How many rows of cars do you see?
1.
How many cars are in the row?
1, 2, 3, 4.
Very good. Now, would my friends, the soft drink bottles, pop over here? Get it? Pop over?
Pop over.
That's good.
Look at these. Thank you. My cap's off to you.
My
The
cap.
cap's off to you. Okay, come on now. Let's describe what we see here. These 2 rows form an array. Count the rows.
1 row, 2 rows.
How many bottles in a row?
1, 2, 3. 3 bottles in the first row.
And 1, 2, 3 bottles in the second row.
How many bottles altogether?
1, 2, 3, 4, 5, 6.
That's correct. 3 in one row and 3 in the other row are 6 altogether. 3 plus 3 equals 6. We can also say 2 3s equals 6. 2 rows of 3 bottles in a row equals 6 bottles altogether. This idea is what we call multiplication. Thank you, Bottles. You've shown us an interesting connection between addition and multiplication. Now perhaps my hard-boiled buddies would help.
Hard boy.
We got it.
Let's take a look at this egg carton. It will help you to understand what I just explained. This is also an array. Now again, let's count the rows.
1 row, 2 rows.
And how many eggs are in each row?
1, 2, 3, 4, 5, 6 eggs.
Can you remember the idea we learned from the bottles?
Oh,
Yes,
2 rows of 6 in a row equals, let's see.
12 altogether.
Yes, 12 altogether.
2 6s equals 12.
Exactly!
Exactly.
That's awful.
Congratulations, you've unscrambled the first step to multiplication. Now we can go on to the second step. Now here's some help from some friends who are always under my feet. A pair of socks, or we can say a set of socks. Thank you.
Wow, here comes more.
Look at him. Hey, what's going on?
Yeah, what?
How many sets of socks are there?
4.
How many are in each set or pair of socks?
2. There are 2 socks in each set.
How many socks altogether?
4 sets, 2 in each set.
Yeah, that's 4 2s.
4 sets of 2 equal 8. There are 8 socks altogether.
That's the way to sock it to me. That's the way to sock it to me.
You're funny.
You've got this idea. Thank you, friends. That's all for now. Shoo! Now, let's do one more set to jar our memories. Okay, watch this.
Wow.
Look at that. Did you see what I saw?
Sure. They're going to help me make a point. There are 4 jars with 5 pencils in each. You can think of each jar as a set. 4 sets of 5 equals 20 altogether. I think this is fun.
I do too.
Yeah.
This is fun.
Now, we've talked about arrays, and we talked about sets. Would the cars come back on, please? I didn't mean back in, I meant back on. Oh, boy. Now, let's look at how an array can change itself around and still have the same number of things in it.
Look at those cars lining up.
They formed an array, just like the eggs in the egg carton. Remember? 2 rows, 6 in each row. 12 all together.
Hey, where are they going now?
Yeah, where?
Don't worry, none of them are leaving. They're just moving into a different position to drive home another point. Drive home another point.
Drive home.
Come on.
See, before they were in rows of 6. Now they're in 6 rows of 2 in a row. But there are still 12 altogether. So you can see, not only that 2 rows of 6 is 12, but also 6 twos equal 12.
That's right.
Yeah.
There are lots of ways they can be rearranged.
Wow.
Boy, now they're in 3 rows with 4 cars in each row.
Yeah.
And of course, you know from before how many there are altogether.
Yep.
Sure.
So what would you say about this array?
That 3 rows of 4.
Equals 12.
Right.
Right. Let's restate the idea in a sentence.
That was a sentence.
No, I mean a mathematical sentence. Around our house, we say that 3 times 4 equals 12. Times means to multiply, and we use an X to represent multiplication. Now, if 3 times 4 equals 12, we can also say...
I know.
It's the same as 4 rows of 3 or 4 threes.
Yeah, or it would be 4 times 3 equals 12.
Right. 4 times 3 equals 12 is the same as 3 times 4 equals 12. Well, now you've got it. That's multiplication. I told you this was a mathematics film. Thanks for being such a good audience. And a special thanks to all my friends who helped me. Hey, those are my socks. Hey, come back here. Wait a minute. Socks, hey, socks.
Beep, beep.
What is this, a ball game?
Yeah, what's going on here?
No, this isn't a ball game. It's a mathematics film. It's about division.
A mathematics film about division?
What's division?
Let's use some of these objects to find out about division. Could the crowd quiet down? And could you rowdy balls roll on out of here? Could we have the shoes walk on in? All right, we have 10 shoes here. Let's just count them to make sure none of them have walked off.
1, 2, 3, 4,
5, 6, 7, 8, 9, 10.
Okay, like I said, we have 10 shoes. None of them have walked off. Now, as you can imagine, we want to put these 10 shoes into pairs. A pair is 2 things that go together, like a pair of shoes. Let's see how many pairs we have. Could 2 of you shoes walk over together? Good. Now another 2. That's right, shoes. Keep going until you're all in pairs. None left over. Wonderful. Now that all the shoes are grouped in pairs, how many pairs are there?
1, 2, 3, 4, 5.
There are 5 pairs of shoes or 5 pairs of 2 shoes.
Right. So 10 shoes grouped into pairs of 2 equals 5 pairs.
Oh.
Another way of saying group into pairs is to say divided into groups of 2s. The symbol for divided is this. Now, how's this written as a mathematical sentence? 10 divided by 2 equals 5. Okay, Shoes, we're going to give you the boot. You can walk out now. Get at the boot. I said the boot.
What is this, musical chairs?
Well, in a way, actually, we're going to use these chairs and tables to do another division problem. We have 13 chairs here, and we can put a group of 4 chairs at each table. So let's put the chairs in groups of 4 at a table and see how many tables we fill.
Wow! Is that neat?
There they go again.
Well, now how many groups of 4 did we make from the 13 chairs?
3 groups.
Correct. 13 chairs are put into groups of 4, and we get 3 groups. Now, how would we write that as a mathematical sentence?
Let's see. 13 divided by 4.
Equals 3.
That's right. So far.
Yeah, but what about that remaining chair?
Good question. I was just getting to that. When you do division, things don't always come out even. Sometimes there's something left over. We call it the remainder, and write it like this. 13 divided by 4 equals 3, with a remainder of 1. Okay, you furniture can go take a break. Before, we knew how many were in each set, and we had to find out how many sets. Now let's do some division where we know how many sets there are and then have to find out how many in each set. For instance, let's say each set is a team of balls. We want 2 teams, and we want to find out how many balls on a team. There are 12 balls out there. Okay, you balls, group yourselves into 2 teams.
Wow!
Are they great?
Look at them go!
Now the balls have grouped themselves into 2 teams or 2 sets. And how many are in each set?
1, 2, 3, 4, 5, 6. There are 6 balls in the first set.
And 1, 2, 3, 4, 5, 6. 6 balls in the second set.
Right. There are 6 balls on each team, or in each set. Now, how would you write that as a mathematical sentence?
Let's see. We started with 12 balls divided by 2 equals 6 balls.
Right. 12 divided by 2 equals 6.
That's right. You really bounced out that answer.
And I'll bounce it right back to you. And there weren't any balls left over.
We could even say remainder 0. Well, it was fun playing ball with you guys.
Yeah, way to go. Okay, brilliant. Okay.
Good going.
Hey, we're through with you guys now. Now, here we have a pack or deck of 25 cards. Let's pretend we have 3 players. So deal the deck out into 3 equal sets and find out how many cards in each set. That sure was a fast deal. Now, let's see how many cards per set.
1, 2, 3, 4, 5, 6, 7, 8. 8 cards in each hand or each set.
You didn't use them all. There's 1 left over.
Right. So we had 25 cards, and we put them in 3 sets of 8 cards per set, with 1 left over. So how would we write the division sentence?
25 divided by 3.
I know.
Wait, 25 divided by 3 equals 8, with a remainder of 1.
That's right. Should we try some more?
Yeah.
This is fun.
Okay, back into the deck. Cards. Let's say that 2 more people joined the game and that there are 5 players this time. We want to deal the cards into 5 sets. And now what would you say about this?
Well, there are 1, 2, 3, 4, 5. 5 cards in each hand, or each set.
And how would we write that?
Let's see. 25 divided by 5 equals 5,
Remainder 0.
That's terrific! Let's send the cards back and try one last game. This time we have 7 players.
There's 7 sets and only 1, 2, 3 cards in a set.
And there's 1, 2, 3, 4 cards remaining.
So the division sentence is 25 divided by 7 equals 3.
Remainder 4.
Well, now you've got it. That's division. You really deserve a big hand.
Big hand.
Hi, people.
Hi.
What do you need all that for?
We're learning to measure how much room things take up. You want to learn too?
We'll learn later. We have to get ready for our party. See you later.
I'm so glad Pat and Pam invited me. I love birthday parties. I'm going to give Pat and Pam my whole pile of colored beans. But what shall I put them in? In this little bottle? That's not enough space for all these beans. This box has lots of room in it. Actually, there's too much space in this box. The beans don't take up that much room. This should have just the right amount of room for these beans. Ah, good. The box is full. The space in this box is just enough space to hold all these beans. I hope they like my beans.
I wish we had some new glasses for our party. When you compare them, you can see that each one of these glasses holds a different amount.
This one holds less than most of the others.
This little one hasn't much space inside it. It holds least of all.
This one has a lot of space inside it. It holds more.
This is the biggest glass here. Compared to the others, this glass holds the most.
At my parties, glasses are all the same. Glasses that are the same size have the same capacity.
What did you say?
I was talking about how much things hold, and I said capacity.
I thought you said capacity.
Excuse me, but we heard you say capacity.
We know that the capacity of this glass is more than the capacity of this one.
But we'd like to know how much more.
How do you measure capacity?
I'm very sorry, but you'll have to ask someone else. Perhaps you can ask those new young people. Have a good day.
Activity 3. Compare the capacity of the big container with the capacity of the little container. Choose any small container to use as a unit of measuring. We're doing that one. Did you mark the level of each cup?
Yes, we did. The little container holds 2 units, and the large container holds 4 units.
See, to measure, you compare how many units.
Oh, that's not so hard.
Now we can use very small glass and compare all our glasses.
Now we better not forget to order the lemonade. every party in town will serve our lemonade now that we have finished our new root beer and lemonade factory.
I'll read our secret recipe while you and Boris mix the ingredients. You ready, Boris?
Boris ready?
10 bottles of fresh spring water.
10 bottles of fresh spring water.
3 bottles of lemon juice.
3 bottles of lemon juice.
And 1 bottle of sugar.
And 1 bottle of sugar. Let's taste it.
Okay, it should be great.
Ooh,
So sour.
We put in just what you said.
Let's look at the bottles. Water, lemon, sugar. Well, that's right. Wait a minute. I'll bet when you measure, you should use bottles the same size. Boris, put in some more water and sugar while I answer the phone.
Boris put.
Root beer and lemonade factory? We'd like 3 bottles of your most delicious lemonade for our party Saturday.
Yes, sir. 3 bottles of our delicious lemonade for your party Saturday. They'll be there, sir.
Anybody like some leftover lemonade?
What are you doing with all that lemonade?
We ordered 3 bottles of lemonade for our party, and look what they sent.
Did you get 3 bottles?
But look how much they hold.
How much does a bottle hold? Okay. It depends on which bottle. They make all sizes. Sure, you're thinking of one capacity.
And they were sure thinking of a bigger one.
But that couldn't happen if you or the lemonade company knew about a liter.
What's a liter? A liter is this much space, whether it's full
A liter.
or empty. And these are all 1 liter, a little more than this milk carton. The space can be any shape, but it still has a capacity of 1 liter.
Ah, if we had ordered our lemonade by the liter, no problem.
Right. So here's a liter measure to remind you.
I think we should get some liter bottles. We're going to open a lemonade stand and sell our lemonade.
What's that noise?
It's some kids, boss. They're building a lemonade stand right outside our chocolate fudge factory. I'm thirsty. Can I go get some?
In a minute. How much are they selling it for?
30 cents a liter. Hey, boss, how come we don't measure our chocolate fudge by the liter? It takes up space, too.
Well, it's like this. Space, like in this bowl, we can fill and empty. We call that space capacity. But when space is filled up by something solid, like our blocks of chocolate fudge, then we talk about volume. Got that?
Maybe I got it. If I want to measure this bowl that's empty or this bowl that's full, then I'm measuring capacity. But when I want to measure how much space is taken up by these solid blocks of delicious chocolate fudge, then I'm measuring volume.
Right. Both times you are measuring space. But this is capacity and this is volume. Now you can get some lemonade.
But I have one more question, boss. When you have a big volume like this, what kind of units do you measure it with?
In the fudge business, that's easy to answer. To measure volume, you divide the filled up space into cubes, like we divide up our fudge. Presto! Cubic units.
To find the volume, divide it into little cubes and count them.
Sure. This big block of chocolate fudge has a volume of 24 cubic units. The big box we packed them in has a volume of 10 cubic units.
I like cubic units. Look at all the shapes I can make that have a volume of 24 cubic units.
I think it's time for your lemonade break.
Good afternoon, sir. Some cool lemonade?
Yes, please.
How much lemonade would you like? We have glasses of different capacity.
Ooh, I'm very thirsty. I'd like the big one.
If you like it, sir, we have this bottle with a capacity of a whole liter. You may like to take a liter of lemonade home with you.
It's delicious. I would like a liter to take home. Here you are.
Thank you.
This is very good lemonade. And you know what? After I drink the lemonade, I'll have this fine bottle that holds exactly 1 liter. The standard unit for measuring capacity. I'll be able to measure the capacity of all kinds of things. Big bottles, dish pans, wash basins. It will be fun. Why don't you find a liter bottle and measure capacity too?